So I think my talk will be a little bit different compared to the other talks, because I'm not talking about one particular research project, but the content of my talk is based on a special issue that some colleagues of mine and I published last year, which was on value and waste in software engineering. So in this talk, I'm gonna present some of the research presented in papers, and I also try to explain like why we should care, why it matters. And I think I will stay rather at a high level, but I include a URL here. So if you're interested in the details of the work that I'm going to present, you can go to the URL, and all the papers, they should not be behind a paywall. So you should be able to read and go into the actual technical nitties and gritties of the actual research. And if you can't remember the URL, I also included in the footnote if you want to refer to it. Okay, but what's the big picture? What's the maybe motivation for my talk? So, well, we have value and waste, but in practice, it may be challenging to really think about value and think about waste and think about how we can reduce waste or how we can increase value if we don't really have a conceptualization of these terms or of these ideas. So this is what I want to do, to think about, well, how can we conceptualize waste? How can we conceptualize value? And then use these more concrete definitions to actually proactively address value and waste in development. So to start off, so one paper that actually did not appear in the special issue, but I think it is still relevant, is a paper that presents some research that looks into what actually is waste. And for each of the findings I present, also at the bottom, the source of the evidence. So if you wonder, well, what is this based on, what I'm going to talk about, there is a brief summary in the blue boxes at the bottom of each slide. So there was one study that looked into, well, what is waste, and it came up with a definition of waste in software engineering, and also 9 categories of waste, including their cause. So why do we even have the types of waste? And I will refer to some of these types later on. But well, you may wonder, okay, what's the point of knowing this? Well, if we know these points, or if we know these types of waste, we can actually talk about them in our team. We can actively address them and maybe consider them in our planning, in our projects, in how we design and develop software. So let's have a look at the first waste-related issue here. So code reviews, I think a lot of things have been written about code reviews. There are a lot of blogs out there. A lot of people have opinions about code reviews, and I think there will be some more talks also in the context of this series of talks about code reviews. So we do actually know a lot already about code reviews. So what I would like to highlight in the context of waste is that bad code reviews can be a source of waste, and to address this, or to mitigate or to reduce waste in the context of code reviews, well, we can actually look at what makes a bad code review. And there are a lot of empirical evidence out there what is classified as a bad code review. And well, this study, it identified so-called review smells. For example, lack of review or looks good to me, which means reviewers don't really review the code in the first place, or they just review it superficially, which could then lead to the waste of rework that we later need to go back and rework what we have done, the design of the code. Review buddies is another review smell, which means that we just ask our friends to review our code, maybe just the people who work on the same parts of the code. So there is not really a knowledge sharing going on, or code review doesn't really help knowledge sharing within a team. There are some other reviews like ping pong, which then leads to inefficient communication when the reviewer and the author of code just go back and forth to discuss the code. Or sleeping, which is an interesting smell, which means that the reviewers are not even replying. So it's another source of waste because we have to wait. So the developer who wrote the code needs to wait until the review comes back. And the 2 remaining smells would be, well, we have large change sets. So for example, the amount of changes in the code that we have to review is very large, or we've simply missed the context of the change just made to the code that we're going to review, which then could lead to a very high cognitive load. And again, in the end, probably a waste of time in the long term. Now, again, the question is, why does this matter? Well, if we are aware of these types of smells, we can actually plan our review activities, we can communicate expectations for code reviews, and we can even use these anti-patterns or smells of reviews to train new reviewers in our organization. Okay, let's stay at the code level. Another waste or form of waste, I think, is technical debt. And again, a lot has been written about technical debt, but one question that often, or actually I think always comes up is, well, what do we actually fix? How do we fix it? And who should fix it? Well, this contribution to this special issue that we published found that not all types of technical debt are actually fixed the same way, and some types of technical debt are fixed by those who introduce them, and some types are fixed by other people, and some types of technical debt maybe are never fixed. Okay, what can we do with this? Well, if we know that some types are less likely to be self-fixed, so for example, design debt, we probably need to come up with dedicated activities or maybe dedicated maybe time in our development to fix these types of technical debt. For other types of debt, for example, code debt or defect debt, it's often the developer who introduces it who then also fix it. So for these ones, we may actually not plan fixing initiatives or fixing activities. Also, well, what can we draw from this is that when it comes to types of technical debt that are not self-fixed, we probably need to assign them to people, to dedicated people. And this research argues, well, design debt, for example, we probably should assign it to more senior people, because those who introduce design debt, if they are junior ones, they're also often not really interested in fixing it in the first place. Okay, so these were two examples, and the third and last example is a little bit different, and it looks at value, but it looks at value from a different perspective. It's not about value in terms of money, or value in terms of features, or value in terms of time we save, but it's value in terms of human values. And the question is, well, how can we integrate human values in software? Because as a responsible professional or as software developers, we should not only make sure that we build software that is useful for our clients or customers, but we also should build systems that support or at least do not violate human values. Now, there are lots of literature out there on human values and taxonomies, definitions, but it might be quite difficult for a software engineer or software developer to understand, well, how do I translate human values into something that we can represent in code? And this is where this contribution comes in, this paper at the bottom, because what this paper tried to do is, well, it looked at how human values are discussed amongst developers of software projects, and then it tried to come up with conceptualized descriptions of these human values so that they are more actionable or can be operationalized by software engineers. So just to give an example for two human values, I mean, there are more. I just put two examples here, dignity and inclusiveness. So they could be conceptualized into, for example, a dignity into maintain honor and respect for users. And once we have that contextualized description of that human value, we can then go one step further and define actual requirements. So for example, based on this description, we could think of, hey, what kind of user information do we keep in our app? How is it shared? How can users unsubscribe? Do users have ownership, for example, about their information? So then this high level, maybe abstract concept of dignity, which maps to human value, becomes something much more concrete. And the same for inclusiveness. So what the research found is we can translate inclusiveness into facilitate different origins, languages, cultures, and knowledge. And then based on that, we can go one step further to come up with concrete requirements or constraints for our software. Okay, so that's all I wanted to talk about. Just to summarize, we do already know a lot about value and waste. And in this talk, I just wanted to give you some examples. And well, what are the takeaways? Well, we know a lot about review smells, so why don't we use that knowledge in order to plan our reviews, in order to train maybe novice developers, or in order to also communicate the expectations about reviews within our organization. When it comes to technical debt, well, we can use our empirically grounded knowledge on technical debt to decide how to fix it, and we can decide what kind of activities we focus on. So for example, if for whatever reason we would like to spend a day or two on fixing technical debt, it's probably better spent on fixing design debt than on fixing code debt, because code debt tends to be self-fixed by developers. And the last but not least, when it comes to human values, well, we now have a contextualized description of human values, and we can use that to identify more concrete product requirements, and in the end to build responsible software. Yeah, so if you have any questions, feel free to email me, or if you want to know more, feel free to email or just leave a question with Mike. And yeah, that's all I had for today.